Now that we're starting to talk about what we see from the Earth, we actually tell ourselves a convenient lie. So we realize that this isn't true, but we use it anyway because it kind of helps us wrap our minds around exactly what it is we're seeing. So the lie that we tell ourselves is that the Earth is the center of everything, and that the Earth is surrounded by a great ball, what we refer to as the celestial sphere, and it is on this celestial sphere that we have all of the stars. So all of the stars are embedded within the celestial sphere. So kind of, at least for me, you can kind of see the difference between what's actually going on and this idea of the celestial sphere from a discussion in The Lion King. Hopefully you've seen the movie The Lion King, but there's this one scene where you have Timon and Pumbaa, and they're both out stargazing. And Pumbaa says to Timon, "Hey, what do you think those glowing things are?" And Timon responds, "Oh, they're fireflies that got stuck up in that bluey blacky thing up there." That's the idea of the celestial sphere, that there is actually something that is surrounding the Earth, and the stars are embedded inside of it. Now, then Pumbaa responds, "Oh, I thought that they were giant balls of gas burning millions of miles away." Now, that's what's actually going on. We realize that there is not actually a giant sphere surrounding the Earth, but to kind of help us understand and wrap our heads around what's going on, how it is we're viewing things from the Earth, we pretend as if there is a celestial sphere. So with this idea of the celestial sphere, we can now start to define special locations. One of these is the celestial equator. The way we define the celestial equator is we take the equator of the Earth and we then stretch it out until it hits the celestial sphere. This then defines the celestial equator. So the celestial equator is the projection of the Earth's equator onto the celestial sphere. We can then also define the north and south celestial poles. We do the exact same thing. We take the Earth's north pole and stretch it out until it hits the celestial sphere. That defines the north celestial pole. We take the south pole of the Earth and stretch it out until it hits the celestial sphere, and that defines the south celestial pole. So what object is really close to the Earth's north celestial pole? It's Polaris, the North Star. It is very close. We'll see in a little bit that it's not exactly on the North Celestial Pole, but it's close enough we can use it to define and find true north. Now there's one other special point on the celestial sphere that I'd like to define. This is the zenith. The zenith is the point on the celestial sphere that is directly overhead of the observer. Now, because this is defined from the observer, it actually changes with location. So, as an example, imagine that one night you go out and right on your zenith, you see a comet. And knowing that you have an aunt who's very excited about astronomy, you immediately run in and call your aunt in New York City and say, "Hey, look up at the zenith. Do you see that awesome comet?" What's she going to respond? She's going to say, "No, there's no comet on my zenith. My zenith has nothing on it." Well, that's because of change of location. Because you're not in the same place, your zenith, the point directly overhead, is going to be very different. Now, in other situations, for example, if you and I were standing outside and I look up and say, "Oh my gosh, look up at the zenith, do you see that comet?" Then we're going to be pretty much looking at the same place and we can communicate easily. So the zenith is always directly overhead above the observer, which means it's going to change depending on location. Now that we have defined the celestial equator and the north and south celestial poles, we can now define a coordinate system, a way of figuring out exactly where the objects are located on the sky. So the coordinates that we often use in astronomy are right ascension and declination. These are very similar to latitude and longitude. So latitude and longitude are ways of determining positions on the surface of the Earth. Latitude is measured north and south from the equator. Longitude is measured east and west. Now, when dealing with the celestial sphere, again, we use right ascension and declination. Right ascension is measured east and west, meaning that it's very similar to longitude. However, there is one big difference. When measuring right ascension, we measure in hours, minutes, and seconds, Notice hours, minutes, and seconds. These are units of time. We actually measure right ascension in units of time. Now, the reason why we do this is because the sky is constantly changing east to west. Stuff rises in the east, arcs across the sky, and eventually sets in the west. So because of this change, it makes sense to keep track of right ascension using time. Declination is measured north and south of the celestial equator, meaning that it's going to be very similar to latitude. Now, declination is measured in degrees, arc minutes, and arc seconds, similar to how we actually measure latitude and longitude on the Earth. Although we are discussing this, don't freak out too much. Don't worry, I'm not actually going to ask you to try and locate something on the sky using right ascension and declination. Just remember what they are, how we use them to measure, and that right ascension uses hours, minutes, and seconds, and declination uses degrees, arc minutes, and arc seconds. Hey, here is our second lecture quiz question. Which point is always directly above the observer? A. North celestial pole, B. Zenith, C. Equinox, or D. Ecliptic? Go ahead and think about it, and we'll discuss in just a bit. So what point is always directly above the observer? The answer is B. Now, I'm going to go ahead and say that some of these questions could actually be rephrased as, did you watch the video? However, that's only some of them. Some of them are actually thinking questions where I would like you to stop and actually ponder. Now, depending on your location on the Earth, you're actually going to get a different view of the celestial sphere, what's actually going on up in the sky. And this is because the Earth is a round ball, and depending on your position on it, will determine how it is that the Earth rotates, and therefore what region of sky you're able to see. As an example, in this image, we're actually looking at somebody at 35 degrees north latitude. Here in Utah, where we are, is somewhere between 41 and 42 degrees north latitude, which means this observer is actually a little bit farther south than we are. Now notice that because of where this person is positioned, as they look south, there's going to be a region of sky that they're never going to be able to see. From their point of view, looking south, part of the sky is always going to be below the horizon. Part of the sky will always be blocked by the Earth. And so they will never see this region of sky. As an example, where we are here in Utah, we cannot see the Southern Cross. That is always too far south from where we are. The Earth is always blocking it. It is always below our horizon. There's going to be another region of sky where we have some stars that are going to rise and set. So these ones will start out below the horizon, they'll rise up, and then they will dip back below the horizon. Then there's another region of sky, in this case towards the north, where these stars, because of where the person is located, the Earth never gets in the way. These stars are always up. These stars are known as circumpolar because as you watch them, they will appear to actually circle around the pole. They'll actually make little circles around the North Celestial Pole. So here we have a view. This is a long exposure. So what they did to get this is they set up the camera facing the North Celestial Pole, and they just left the camera open, recording light for a long period of time. Based on how long these streaks are, we're looking at probably a couple of hours. Now, each of these streaks is actually a star. So these are known as star trails. You can see how it is that the stars have moved over this time. Now, right here at the very center is going to be the North Celestial Pole, and notice this really bright star. That is actually the North Star. And notice it is not exactly on the North Celestial Pole. However, you can see how it is that all of these stars are making circles around the North Celestial Pole, so all of these stars are circumpolar. Now, depending on your location, you'll actually get a different view. So what we looked at previously is what happens at mid-latitudes, so somewhere between the equator and one of the poles. In this case, there'll be some region of sky that is blocked, some region of sky where the stars rise and set, and another region of sky where the stars are always up. Something that is interesting is you can actually, as you watch these stars rise, they're going to make an angle compared to the horizon. So if you have a perfectly flat horizon, what is sometimes referred to as the true horizon, you can measure this angle, and doing a little bit of geometry, you can actually figure out your location, your latitude, north and south. If you're standing right on the North Celestial Pole, so going back up to this image, okay, if you move towards the North Celestial Pole, notice that this region that is always blocked is going to grow and grow and grow, and this region that is never blocked is also going to grow and grow. So if you're standing at the North Celestial Pole, what this means is that half of the sky is now circumpolar, and the other half is always blocked from view. Now, part of what this means is because all of the stars are circumpolar, as they go around, they're actually going to be horizontal compared to the horizon. The stars will move parallel with the horizon. So if you were to stand on the North Celestial Pole and watch the stars over the course of a day, they would appear to circle around you. If you ever want to feel like you're the center of the universe, stand on the North Pole and watch everything spin around you. Now, if we go the other direction, so head towards the equator, then, again, going back to this image, as we get closer and closer to the equator, this region where the stars never rise is going to get smaller and smaller, and the circumpolar region is going to get smaller and smaller. So that if you are standing exactly on the equator, there's no circumpolar region, and there's no region that you will never see. If you're standing on the equator, all stars will be able to rise and set. What this also means is as you watch the stars rise, they're going to rise exactly perpendicular to the horizon. So on the poles, these stars move parallel with the horizon. But if you're standing on the equator, then the stars are going to move exactly perpendicular to the horizon. And all stars are going to rise and set. So here is our third lecture quiz question. If you were standing on the equator, then A, stars that rise due east would go directly overhead and set due west. B, the North Star would be directly overhead. C, all stars would be visible every single night. Or D, stars to the north would rise in the east and set in the west, while stars in the south would rise in the west and set in the east. Go ahead and think about it, and we'll discuss in just a bit. All right, so the correct answer is going to be A. Because the stars are going to rise exactly perpendicular, and on the equator, stars move exactly east to west. If it's exactly due east, it will arc directly over your head and then set due west, staying exactly perpendicular with the horizon in its motion. Now, some of you may have thought C, all stars would be visible every night. Although you will see all stars rise and set, we don't see stars during the day. So the stars that are up during the day, we're not going to see during the night. I realize it's a little bit tricky. I was kind of seeing if you remembered what we talked about with the only being able to view stars during the night. So the correct answer is A. That's what you're going to need to mark on the lecture quiz question.